Math 8, Unit 4, Graphing and Slope, Lesson 11, Solving Systems of Linear Equations by Graphing. Your family starts a bed and breakfast. It spends $500 fixing up a bedroom to rent. The cost for food and utilities is $10 per night. Your family charges $60 per night to rent the bedroom. Find how many nights your family needs to rent the bedroom before recovering the cost of fixing up the bedroom. This is the break-even point. So on this, X is going to be the number of nights we rent it out. C is the cost, what it cost us, and R is the revenue that we bring in. So let's go through cost first. If it costs us $500 to rent, get it fixed up, we're going to start out with a $500 cost, and that's without renting it out at all. Now, after we rent it out one day, we do have fees and stuff, food and utilities of $10 per night. So after renting it out for one night, it's going to be $510. After 2 nights, it'll be $520, then $530, etc. I'll just finish out the table here. $540, $550, $560, $570, $580, $590, $600, and $610. So there's the cost of the room for our family. Now when we rent it out, it is going to be rented out for $60 per night. When we have rented it out 0 nights, it's going to earn us $0. If we rent it out for one night, it's $60. 2 nights is going to be $120, 3 nights $180, and it just goes up by $60 from there. I'll just quickly get the table filled in, going up $60 every day. See, this would be $540, $600, and $660. How many nights does your family need to rent the bedroom before breaking even? Well, they're going to break even when the amount of money they've spent is equal to the amount of money they've made. And that happens with 10 nights. It looks like after the 10th night, your family's going to start making money. Looks like $50 a night, which isn't bad. A system of linear equations is a set of 2 or more linear equations in the same variables. An example is shown below. Y equals x plus 1 and y equals 2x minus 7. A solution of a system of linear equations in 2 variables is an ordered pair that is a solution to each equation in the system. The solution of a system of linear equations is the point of intersection of the graphs of the linear equations. All right, for these 2 linear equations, they are going to cross. I'm not exactly sure where. Just do a quick little graph sketch here. Y equals x plus 1 is going to be an intercept of 1, and it'll be up 1 over 1 from there. And 2x minus 7, it starts down 7. It's going to go up 2 over 1, up 2 more and over 1, up 2 more over 1. It will end up crossing somewhere up there. I'm not exactly sure at the moment. I think it's at 8. I'm not sure. Let's just go to our first example. It will cross though, and the place it crosses will be a solution. The way you're going to solve by graphing is graph each of the equations on the same coordinate plane. You're going to estimate the point of intersections, and then you check by substituting the answers in. So let's start with y equals 2x plus 5 and y equals negative 4x minus 1. Okay, graph each equation. I'll graph equation 1 in blue. The y-intercept is 5, and the slope is 2. That's up 2 over 1. That's kind of off the top of the graph, so I'll go down 2, back 1. And this is where it's really going to be helpful to draw the slope as many times as you can get to fit on the graph. Now let's, in red, I will do the other equation, negative 4x minus 1. I go down 1, down 4 over 1. I can also go up 4 and back 1. And there is negative 4x minus 1. Estimating the point of intersection. Well, it sure looks like it is crossing exactly right there. That is the point negative 1, 3. So it looks like the solution's negative 1, 3. Now we're going to just quickly check that solution in both equations. So y equals 2x plus 5. I'm going to plug in the point negative 1, 3 and see if it works. This is 3 equals negative 2 plus 5. That is true. Let's try it in the other equation. Y equals negative 4x minus 1, and plugging in the point negative 1, 3 for x and y. This will give us 3 equals 4 minus 1, and that is also true. So because this point, negative 1 comma 3, makes both of the equations true, it is the solution to this system of equations. It's the point where they cross. Let's look at some more examples. And we don't need to have all of this showing at once. Let's do this first. Y equals x minus 1 and y equals negative x plus 3. Let's go with y equals x minus 1 in green. It's got a y-intercept at negative 1. The slope is 1 over 1, so up 1 over 1. It's going to go up along this diagonal, and then I can go down and back as well. So there's y equals x minus 1. Y equals negative x plus 3. It starts with a y-intercept at 3. The slope is negative 1 over 1, so down 1 over 1, and up 1, back 1, and we get this graph. It looks like it crosses right here at the point 2, 1. So let's verify that that is the correct solution. Plugging in the points 2, 1. Let me do a little bit of erasing. If I plug in 2, 1, does 1 equal 2 minus 1? That is true. It does go through that point. Now let's try 2, 1 here. Does 1 equal negative 2 plus 3? That is true as well. So 2, 1 is the solution to this system of linear equations. Let's look at our next example. Y equals negative 5x plus 14 and y equals x minus 10. Wow, those are kind of far apart. I think we'll have to count by twos here. That still doesn't get us up to 14, but I'll just have to do that. Negative 2, negative 4, negative 6, negative 8, negative 10, and negative 12. And we probably should count by twos going this way as well. Negative 2, negative 4, negative 6, negative 8, negative 10, negative 12 going back that way. I guess I should have these a little closer to the y-axis. Okay. Now graphing. Let's go ahead and do negative 5x plus 14. It has a y-intercept at 14. Now negative 5 is going to go down 5 and over 1. So down 2, 4, 5, and over 1. Down 1, 3, 5, and over 1. It also does down 10 and over 2. Down 10 and over 2. Looks like we only get those points. I can do another one there and another one there. All right, so this appears to be y equals negative 5x plus 14. All right, let's do the other one. We'll do it in green. It's x minus 10, so I go down 10. It's up 1 over 1 from there. And I get a really nice graph here. It appears that it crosses quite nicely right here at 4, negative 6. So that is most likely the solution. Let's just check that solution into both equations. Let's do a little bit of erasing here. So plugging in 4, negative 6. Is negative 6 equal to negative 5 times negative 4 plus 14? Negative 5, negative 5 times positive 4, it was 4. So there's negative 6 equal to negative 20 plus 14. That is true. So it does satisfy the first equation. The second equation, we're going to plug in negative 6 equals 4 minus 10. 4 minus 10 is negative 6, so it satisfies the first equation as well. So the solution is 4, negative 6 for this system of equations. Y equals x and y equals 2x plus 1. All right, y equals x, that's a slope, a y-intercept of 0, a slope of up 1 over 1. So it looks like it is this nice diagonal, the identity linear equation actually. The other one is y equals 2x plus 1. The y-intercept is plus 1. The slope is 2 over 1, up 2 over 1, and down 2, back 1. And it looks like it crosses very nicely right here at negative 1, negative 1. So double checking to see that that works. Negative 1 equals negative 1. That's true. Negative 1 equals 2 times negative 1 plus 1. That's negative 1 equals negative 2 plus 1, which is true. So the solution is negative 1, negative 1. Okay. Solve the system of linear equations by graphing. Let's go ahead and just, for the video's sake, let's just do one of these rather than all three of them. Now the first one, y equals negative 4x minus 7, I can go ahead and graph that one. No problem. Let's do it in red. I go down 7 because that's the y-intercept, and I go down 4 over 1. I'm going to have to go up 4 and back 1 a few times until I run out of room. And this is y equals negative 4x minus 7. Now the other one, in order to graph it, I'm going to have to start by solving for y. So y equals, looks like negative x plus 2. Well, that's not too bad. Let's graph that in green. So we go up 2, because that's the y-intercept. The slope is negative 1 over 1, down 1 over 1. So it does look like it crosses right here. And that looks like the point negative 3, 5. So let's check to see if that works. Right here, this would be 5 equals negative 4 times negative 3 minus 7. That's 5 equals 12 minus 7. That's true. Negative 3 plus 5 is 2. That's also true. Since it satisfies both equations, it is the solution. Okay, in your practice, on number 1, you're going to match each system with its corresponding graph. Use the graph to estimate the solution, and you're going to check your solution. So it is a matching problem. After you match, you need to identify the solution, you know, where they cross, wherever it happens to be, and then check that solution into the equations. On number 2, you're going to estimate a solution by graphing, and you do need to verify that it is the solution by plugging it in. Number 3, write an equation for the line represented in the graph. So that's just a review of what we did in the previous, not the graph, the table of the previous lessons. Determine whether x equals 4 is the solution to this equation. I would just plug in x equals 4 for all of the x's and see if it's true or not. Number 5 is a situation problem. You're going to write an equation and do some things with that equation. Number 6 is a review of adding fractions. 1 plus a half plus a third plus a fourth plus a fifth plus a sixth. By the way, the common denominator of the numbers 1 through 6 is 60. Number 7 is a break-even table. That's like what we did in the beginning of the video about the bed and breakfast. And number 8 is an open-ended question. I've given you the graph of y equals 3 halves x plus 1. You're going to create another linear equation so the two equations both have the solution of 2, 4, which I've drawn in the graph. Graph the equation and write the equation of the line you graphed. So you're coming up with another equation so that it will create a line that goes through this point so that it will be the solution of the system. So yeah, you're creating a system of equations.